This reaction is a decomposition reaction. It's when a compound breaks down into simpler substances. All right, so I've spaced this out, so it's a little bit easier to balance. I'm going to separate the reactants from the products. I have one aluminum. Now, normally I would keep the hydroxide together. I noticed there isn't another hydroxide on the other side. There's a hydroxide you can say in the water, but I'm not going to force the issue. I'm just going to write these separate. There's 3 oxygens and there's 3 hydrogens. I'm going to see the same elements on the product side. There's 2 aluminums. Now oxygen appears in 2 different locations, so that line is for the oxygen in the aluminum oxide. And that line is for the oxygen in the water molecule. And I have 2 hydrogens. All right, let's balance the aluminum first. I need a coefficient of 2 on the reactant side to balance the aluminum. That's going to double everything else I have because there's only 1 compound on the reactant side. Now I'm going to work on the hydrogen. Don't forget to update every other element in that compound. So, turns out that balances everything else out. So here's the balance equation for the decomposition reaction of aluminum hydroxide. It might be worth noting that typically this decomposition reaction requires heat. And therefore, at high heats, water is likely to be in the gas phase.